So maybe someone else, maybe three,
Yeah.
maybe three, anytime. Okay. And I made a small study, and the background of the study is here. In Japan, we have many large dams and small-scale reservation to support rice cultivation. Dams have spillways and to prevent overflow or destruction of the dam body during flood. And the design flood value of dam is estimated from past rainfall record. However, recent climate change is expected to cause the spillway to be ineffective. This study investigates recent changes in rainfall patterns in Japan. This is context. How long does it take from Indonesia to Japan? 3 hours? 4 hours? 2 hours?
Indonesia is 2 days.
2 days?
7 hours.
I'll flight. I'll flight 7 hours.
8 hours. 8 hours.
8 hours.
Different time zone with
Tokyo.
Yes, yes.
Yeah. I ever been to Indonesia. I've been to East Timor. Oh, East Timor.
Now become the other country though.
Then I stayed in this only one night transit to East Timor. Timor.
Call it Timor.
When I went to Timor, heavy battle has happened. It was 2000. then let's start again. Oh, it's showing the okay. Heavy rain disaster happened in Japan. It's it's happened in northern part of Kyushu and it's Fukuoka or Otani. Okay. Uh, in this disaster, many people died and lost their household. And the next one, it's showing it happened in July 2018. That's the heavy rain damage in Hiroshima and Okayama. At the time, the same, many people died and lost household. And it's this year it happened in northern part of Japan. Prefecture is Akita. And one day rainfall recorded 170 millimeter. And hourly rainfall was 60 millimeter per hour. And in this is the common knowledge that there is more rain on the Pacific side and more rain in Kyushu is starting to break down. In Japan, we had 3,000 kilometers from northern part to southern part. And rainfall is a little different. In the southern part, we call Kyushu or Shikoku, we had much rain and heavy rain. But in northern part, showing Tohoku or Hokkaido, they have not so much rain or heavy rain. That was common knowledge. But in these days, the knowledge is changing. We sometimes had heavy rain in the northern part. Today I'm going to show the change in short term in Japan. The characteristics of heavy rain disasters in Japan. After the World War II, our company, we built a much disaster prevention dams in wide area. So each dam has a spillway, and spillway design flood will be calculated by based on daily rainfall. If the dam has a wide area, the rainfall would be average, will be small. And if the catchment area is small, the rainfall intensity becomes so large. So in Japan, we have much tameike, we call tameike, small pond. Small pond has a small area. And in these days, we had heavy disasters in a small area. Then in that area, after the disaster, interview will be done, and people will say like that. This is the first time I've never experienced, and we never had disasters like this before. They say. So they are thinking about using each memory of last time and a recent time image. They're comparing two images, and they say, this is first time, first time. In Japan, we have approximately 150,000 small ponds. We call it tame ike in Japanese. Tame means storage. Ike means pond. So tame ike means storage of small pond. And in this 10 years, our government defined the importance of small tame ike. And in this case, to they know that safety improvement for the earthquake or flood disaster project by government. The flood volume is calculated using a rational formula. It's showing that Q equal 1 by 3.6 multiply F multiply I multiply A. Each parameter is showing F is runoff rate, and I means runoff intensity. Rainfall intensity during flood arrival time. And A means catchment area. In this formula, I have two parameters. It's one is rainfall intensity, and one is arrival time. I said that in the big area catchment, the flood come to the downside by using a long time. But in the small area, flood will come soon. So in this rational area, rational formula, it needs time and intensity. And the intensity formula will be shown by this three type of formula. The one is Talbot, it's called a Talbot formula. And second one is Sherman formula. And third one, Kuno Ishiguro, Japanese, Kuno Ishiguro formula. In each formula has one same parameter. It's the parameter is I squared 1.0. I squared 1.0 means 1 hour rainfall, 1 hour rainfall. So our intensity will be shown by using 1 hour rainfall, and each parameter A, B, or N, or A or B is showing regional factor. Now, each factor is decided all over the Japan by researcher. And This is three type of rainfall intensity curve. It shows three type of intensity curve, and horizontal number is showing rainfall intensity, and this side is showing the time. Usually, we use show time from 10 minutes to 60 minutes. We can make this curve by using the data from observed record. In this study, I selected 1905 weather station to check change in short-term rainfall change. And it's so hard to show 95 point. So I divided the part from northern part to the southern part to 11 blocks. From northern part, Kaido, Tohoku, I divided two parts, Pacific Ocean side and Japan Sea side, because the rainfall is a little bit different from Pacific side to Japanese Sea side. And the block is parted like this. Number one, Hokkaido, two, Tohoku, three, Japan Sea side, and four, Kanto, and Tokai five, six, Kinki, seven, Chugoku, Shikoku, eight, Sanin, nine, Northern Kyushu, 10, Southern Kyushu, and 11, Southwest Island. And I decided a variation method like this. In front news, you can hear this word in the interviews. I said before, this is the first time we've never experienced anything like this. We never had a disaster like this before. At the time, I said that they are thinking about two memories. One is past and one is recent. So I divided the period into two parts. One is past. Past means 1960 to 1989. And recent means 1992 2019. It shows 30 years and 30 years. And I showed as the rate of change in rainfall pattern equal recent by past. Recent by past. So I checked record of 3 years record and 3 years record, and checked changing method. And this shows it's a little in Japanese, so sorry. So please see the upper side block number. Block number means number one is northern part Hokkaido. The second Tohoku, and for Kanto, we hear in Tokai and western and southern part of Japan. And this figure is showing that white point is showing for 50 millimeter rainfall for 1 day overnight. And gray point is showing 70 millimeter for 1 day, and black point over 100 millimeter. It's showing the not hourly but daily record, and it's showing the rate, happening rate from northern part to southern part. Perhaps you can find out that from the northern part, number 4 Kanto and 3 Tohoku and 2 Hokkaido, the rainy days, heavy rain days is increasing over the rate 1 is increasing. And western and southern part of Japan is not so changing. So in these days, we have this is heavy rain in Tohoku, and they said, I have never had that like experience. They say, Tohoku area. It's showing by this figure, and this is showing that the rate and number of weather station, and rate over 1.0 is increasing area, and how many increasing, and how many number of weather station it's showing. Then over 1.0, it would be 60, wait, 91% of weather station record is increasing in this 30 years. It's saying that number of observation station where the number of days with heavy rain increase is 91%. The percentage of increase in the number of days with heavy rain is most common one. When R is 1 point over 1.4. And next figure is showing the maximum hourly rainfall within 60 years, totally 6 years. It's showing the maximum hourly rainfall. And on the side is showing the weather station. I said that I checked 95 weather station. And it's showing from northern part to southern part. We sometimes say that over 100 millimeter per acre rainfall is so heavy. I have experienced at that time I had 90 millimeter rainfall in the midnight, and I was driving by using fiber so hard, but it's impossible to see foresight. So this graph is showing that southern part, or they had much rain usually. In the northern part, just like number 3, Tohoku, Hokkaido, the rain was a little smaller than southern part. In maximum only rainfall. So we can find it. Maximum hourly rainfall of 100 millimeter per hour occurred in various areas of Western Japan. Rainfall of 80 millimeter per hour to 100 millimeter per hour, which is considered dangerous has also been observed in Tohoku region, indicating that short-time heavy rain is occurring throughout Japan. And this is a heavy rain late, happened late. It's showing that in this figure, I said that in the southern or western part, there's much rainfall. But if I calculate the rate to happen rainfall here, number one, Hokkaido or Tohoku, number 1 to 3, they got much rainfall comparing to 30 years, 30 years. Maybe in Japan, the rainfall intensity is changing to more and more in these 30 years. That's it's showing. It's showing that percentage of weather stations where the rate of change more than 1 point is 63%. In addition, among the weather stations, there are some where the rate over twice. Thus, increases in maximum hourly rainfall are associated with flooding in small catchment. So sometimes we have so heavy rain in the area of Tameike, and sometimes Tameike breaks down. And this shows the 1 year return period only rainfall. I said when we calculate the spillway flood volume, we use 100-year return period rainfall. I said, and in this figure, it's showing that it's nearly similar to maximum rainfall in Japan. And it's showing that southern part or western part of Japan, we had much 100-year return period early rainfall. And some year it showed 180, 160 millimeter per inch. And it's showing heavy rains with 100-year return period hourly rainfall of 100 millimeter per hour or more occur frequently in Western Japan. Kyushu and the Southeast Island is particularly so high 100-year return period hourly rainfall. And the next figure is showing that it's showing the rate, changing rate. It's the same maximum rainfall figure. It's showing that there's many point of its rate is over 1.0. So at that time, the place, flow volume or dam should be changed by this rate. It's showing that 100-year return period hourly rainfall is also clearly increasing overall. There are 8 weather stations where a 100-year return period rainfall is nearly double the normal rate. the proportion of weather station with 100-year return period only of more is 46% of the total. As a result, it's clear that the return period of hourly rainfall is increasing throughout the land. And this is conclusion. Number of days with heavy rain is changed in these 3 years. And maximum hourly rainfall, it's the same, changing. And 100 years return period hourly rainfall is changing the rate 1.1 to 1.4. And impact of changes in restoration patterns on social infrastructure. Since 100-year return period hourly rainfall is a factor in design flood calculation formula, there is a possibility that flood volume of dam reservoirs and rivers is increasing. Thank you, and this is all I made. Okay.
Thank you very much for that. In presentation, there are many never experienced. That is keyword of climate change. Keyword problems we have never experienced before. That's a keyword. So precipitation is same as climate change. So now we'd like to invite questions and comments from the floor or online. Anybody? Please.
Thank you very much, Prof. Chihara, for your excellent presentation. So my period is that the impact of this increasing return period of rainfall is the increasing of hazard. Is that clear? Okay, hazard, for example, is the increasing risk for flood.
Yes.
Especially to the dam and etc. I'm sorry, but since I am from my expertise is agriculture, what is the impact of this increasing return period of rainfall in the aspect of plant growth and production? Thank you.
Perhaps the 100-year return period rainfall data is used to. Oh, sorry. 100-year return period rainfall data is used for the design of spillway. And like that, rainfall will stop within 1 or 2 hours. So it will not give so bad effect to the plant or to in the farmer. Okay. Okay.
Probably. Please go ahead.
Thank you. I think I am the only one from psychology. Psychology. It's very you said that when the rainfall increasing and people talk, it never happened before. Yeah, it never happened before. It is like I hear in Indonesia when Merapi mountain eruption in 2010. They thought it never happened. So earthquake in Yogyakarta 2006, it never happened. And but this disaster, I think not change enough about how they will mitigate the risk.
Mm.
And how about the rainfall impact for person, whether they're more concerned about this risk? Thank you.
Mm. I studied this research. Uh, I said that I'm a dam engineer, so I designed about 10 dams, and at the time I decided dam uh, uh, spillway protesters, and um, we said that this is the first time. When I was young, then I designed much dams, and at that time I decided spillway design, and but after 30 years, they said that this is I've never experienced, and I designed 30 years ago, and in these days the rainfall is changing. Maybe I have to change the spillway design flood volume because other than before 30 years, the rainfall data is so old and it's changing. And in the broadcast, people say that this is the first thing, maybe something changing. At the time, I thought, I must check again flood condition. I've ever designed over 30 years ago. Uh, uh, that was that's why I started this study.
And how about people respond? How they perceive this risk?
Mhm.
Whether people when they see that this change much,
Yes.
change much, and they more concerned and maybe change their behavior to more concern or need to mitigate this risk.
Mhm.
Probably to mitigate risk, spillway should be redesigned. Probably is it right?
Yeah.
Uh, for different expertise people, I explain a little bit. Return period of 100 years
Yeah.
means magnitude appears once in 100 years. So using that return period, spillway is designed. But according to this data, rainfall intensity changes.
Yeah.
So previous 100-year rainfall intensity is smaller than current
Oh, yeah.
precipitation pattern. So if more than 100 years return period precipitation appears, it overflows. Then dam should be collapsed.
Yeah.
So very dangerous. So he probably proposed to redesign and make spillway bigger. Is it correct?
Thank you.
Thank you. Thank you. Yeah. Okay.
Any other questions?
Broadcast was a starting point for me on something changing. At the time, I should do this research. I thought
May I ask one question? Is
You any question?
平松
may I ask one question for me? In chapter 3, you showed some figure that chapter 3.
Chapter 3.
Yeah, this one.
これね。
Next slide. Yes. Right. That's one. Yeah. In even small country Japan, there is some difference in rainfall pattern change. According to this figure, northern part rainfall in northern part is increasing.
Yes.
Is it correct?
Yes.
That's
right.
Is there any reason why northern part?
Maybe this is the climate change.
Just climate change. But if it is due to climate change, southern part is not so much changed,
Yes.
but northern part changed. So I'd like to know the reason.
Maybe the southern part rainfall pattern is
You
going up
need
to
please
the
use
northern,
the microphone.
northern part.
Mic.
Oh, sorry. We have rainfall pattern, and we had much rainfall in southern part. I born in Kyushu. When I was child, we had so heavy rain. But when came to Nagoya, and there's not so much heavy rain. Well, I was so surprised. Maybe the Nakano sensei is the same. Yes. But in these days, rainfall condition in the southern part is going up to northern part, because the high pressure zone of Pacific Ocean is moving to northern part, and temperature of sea is going up. It's said. So in the northern part or in the sea, the temperature of the sea is going up, and it will make heavy rain in Tohoku, Hokkaido. I think.
Thank you very much. Probably similar phenomena is appearing in other countries.
Yeah.
So next, please investigate foreign countries.
Thank you.
Okay, thank you very much. Any other questions? Online, okay. So thank you very much. Thank you very much.
Thank you.
And in this debate session, one presentation only. So we take coffee break. Thank you very much.
Thank you very much. You are so poor English.
No, very good sensei.
You're so kind. Thank you. Thank you.
So from